Welcome to AI Podcasts. I'm Marcus, and with me is my co-host Maya. Today, we're digging into a fresh AAAI paper called VIoTGPT.
Hey everyone, so Marcus, give me the quick headline first. What's the takeaway?
TLDR, a small language model, is trained to act like a planner that schedules vision tools for video Internet of Things. Think city cameras, lots of specialized models, and an agent that decides which tool to call, in what order, to answer a question, and it works noticeably better on multi-step tasks than the usual out-of-the-box chat models.
So it's not trying to be the smartest vision model ever. It's more like a project manager for vision tools.
Exactly. Picture an orchestra. The tools are the instruments, and VIoTGPT is the conductor making sure each one comes in at the right time.
Who's behind it?
Led by Yaoyao Zhong and the team at Beijing University of Posts and Telecommunications, with Huadong as a key senior author.
All right, before we get into the how, help me with the why. What makes video Internet of Things hard in the first place?
Two big things. First, volume. City cameras create a fire hose of video. Second, variety. You need a toolbox of specialists. One model for faces, another for person re-identification, another for vehicles, another for violence or fire detection, and so on. The hard part is deciding which tools to use, in what sequence, and how to pass outputs from one into another.
That scheduling problem. It's like planning a trip with many stops. If you pick the wrong order, you waste time and miss the destination.
Right. Prior work explored letting language models use tools, but usually in generic settings or with closed models. And most didn't focus on the messy multi-tool chains that real surveillance workflows need.
So what's the core idea here?
Treat the environment as three pieces. One, a video knowledge base you can query, like a catalog of city scenes and clips. Two, a toolbox of vision specialists. And three, a compact language model that thinks out loud, picks a tool, reads the result, and decides the next step until it can answer the question.
Thinks out loud?
A think-then-act loop. The agent reasons in small steps, takes an action by calling a tool, looks at the tool's output, then updates its plan. That loop repeats until it's confident enough to respond.
What kinds of tools are we talking about?
A mixed set. Human-centric tools like face or person re-ID and pose, or action recognition. Vehicle-centric tools like license plate and vehicle re-ID. And event-related tools like scene, smoke or fire, and violence detection. Roughly a dozen in total.
Nice spread. How does the agent learn to pick the right tool rather than just guessing?
They fine-tune a small open model, around 7 billion parameters, using instruction data that's formatted in that think-then-act style. The training examples show good tool choices, proper arguments, and how to read observations. Over time, the model learns patterns like, if the question is about whether the same person appears across cameras, you call re-ID rather than face recognition. Or if it's about a car leaving a lot, you might combine vehicle re-ID with license plate reading.
And the video knowledge base, is that just a big pile of clips?
Structured a bit more than that. The system indexes video with city-level tags and scene descriptors, so the agent can ask for the right slice of footage before it calls a tool. It's like saying, show me the clip from the north entrance around rush hour, then run re-ID on that.
Got it. What did they compare against?
Untuned base models of similar size. Also a widely used chat model in zero-shot and few-shot prompting. They evaluate in two modes, single-tool tasks, where one good call solves it, and interrelated tasks where you need a plan, tool outputs feed forward, and small mistakes snowball.
And the metrics, how did they score it?
4 checkpoints. 1, did the agent decide to use tools at all when it should? 2, did it choose the right tool? 3, did it form the right inputs and arguments? And 4, the big one, did the whole pipeline answer the question correctly in the end?
I like that last one. Feels closer to reality.
Exactly. End-to-end is what matters to operators.
So where did VIoTGPT shine?
The biggest gains show up in those interrelated multi-step tasks. The tuned agent followed the format, chained tools sensibly, and landed the final answer more often than untuned models in the chat baseline. On single-tool tasks, the big chat model was already very good, but the fine-tuning still made the small models stronger and more reliable.
Can you walk me through a simple example, like what an agent would actually do?
Say the question is, did the person in the red jacket who got out of the blue car enter Building A? The agent might query the video index for the parking lot scene, call a vehicle detector to find the blue car, read the license plate with a plate tool, then use person re-ID to track the red jacket person from the car to the walkway, and finally a scene or entry detector to confirm the building entrance.
And if it picked the wrong tool, like action recognition instead of person re-ID, it would get lost halfway.
Exactly. The value is in making the right call at each step.
Any hints on the training recipe beyond the think then act style?
They use parameter-efficient fine-tuning, the LoRa approach, so the compute footprint stays practical. That matters if you want this to live near the edge or scale across many cameras.
What about data quality? Where did the instructions come from?
A mix, seeded from practical tasks, expanded to cover language variety, then curated by experts. That helps the agent understand different ways humans ask the same thing, not just one template.
All right, time for the skeptical questions. What are the caveats?
First, representativeness. The benchmark covers a useful slice of city scenarios in a curated toolset, but real deployments have more tools, trickier assets, and streaming constraints. There could be domain shift. Second, instruction expansion brings the risk of learning the house style of the dataset rather than the wild phrasing you meet in the field. Third, they do not deeply measure live latency and throughput, which matter a lot for city-scale systems.
And of course, privacy and safety. You can be technically right and socially wrong if you ignore governance.
Absolutely. The paper focuses on scheduling accuracy. Any real deployment would need strict policy guardrails, auditing, and privacy controls.
Reproducibility. Are the materials available?
The authors indicate that resources for reproduction are provided, which is encouraging. The one caution is that web-sourced videos can move or vanish over time, so parts of the data may be fragile.
If you were to extend this work, where would you go?
I'd add cost awareness to scheduling, so the agent weighs accuracy against time and compute, like choosing a cheaper detector when confidence is already high. I'd expand the tools to include tracking and spatiotemporal search. I'd also build a tougher evaluation with partial credit, live latency, and stability under noisy video.
I'd push on generalization too. New cities, new camera angles, multilingual instructions, and ambiguous questions. Can the agent ask clarifying questions before calling heavy tools?
That would be powerful. A quick clarification could save 10 seconds of compute and a wrong answer.
All right, bring it home. What should listeners remember from this paper?
VIoTGPT shows that you do not need a giant monolithic model to handle complex video queries. With a small agent that plans and schedules the right specialists, you can make meaningful gains on the hardest part of the job, which is multi-tool reasoning. It is a practical, engineer-friendly direction.
And the gaps are clear. Broader tools, stronger generalization, and real-world performance metrics like latency and cost, plus policy and privacy baked in from the start.
Exactly. Smart orchestration over brute force.
That's VIoTGPT, a conductor for the orchestra of vision tools tuned for the chaos of real footage.
Thanks for listening to AI Podcast. If you found this useful, share it with a colleague and let us know what paper we should cover next.
See you next time.